All right, Ashley, and anybody else, Ishika, we hope this video finds you well. We're in the nth roots of complex numbers, and we're going to use this formula. We say that the solutions are W, and we're going to start with W sub k. I'll explain the sub k here in a second, but it's equal to, we start with R, and do you remember what we did with R in de Moivre's theorem in our checkpoint today? Took it to the nth power. Anybody want to guess what we do in this situation? Very good. So that's the part that stays similar. You can kind of connect that. But then what happens, we take the cosine of theta plus 2 pi k, and we divide that by n. And I know right now you're getting that frustrated feeling in your stomach. You're like, wow, that's no good. What even is it? 2 pi k divided by n, and that's what we have. I can tell you that this is the formula that we're going to use in order to find the nth roots, and I can tell you what it means to find those nth roots, but I can't prove this for you right now. You need to take a complex analysis course in college, and it's above where we're at. So most of the time we can do the proofs. We can't do that right now. So if you're asking where this comes from, unfortunately, that's something that you're going to have to spend a lot of time and a lot of years ahead of you to get to that spot. So we came up with a new variable. We came up with k. K is equal to something special. 0, 1, 2, 3, all the way up until n minus 1. Exactly. So if I were to ask you the fourth root of 1 minus 3i, if I were to start there, anybody want to guess what n is in this situation? 4. That's our root number. So then here's the thing about k. K happens to be 0, 1, 2, 3, 4, all the way up until n minus 1. Well, if n is 4, then what's n minus 1? So k is going to be 0, 1, 2, and 3. Notice how many k values do I have? 4. It matches with my degree. It's just I start with 0, so you stop the one before. Yeah, so if I had the cubed root of 2i, what's my n value? 3, because it's the cubed root. What are my k values? 0, 1, and 2. We all clarify the difference between n and k in this situation? Okay. And so now we are ready to move on to the big battle that we're trying to fight, which is to find these solutions. So flip back to this spot then within your notes. You don't have to look back to that page on your notes. You can simply reference what we have on the board. But we need to now start to flesh this out and iron this out. Went pretty good the previous 2 hours, but without a doubt, I'm going to have to lean in. A lot of good questions came up. But let's try to wrestle through this and see where we get. The square roots of negative 81i. This is what we're trying to compute. Can somebody tell me, any guess what might be in the answer for this? Okay, there might be a 9, might be an I, but other than that, we really don't know, right? Okay, so let's start with n. Can somebody tell me what n is? Dos. Spanish for 2. Anybody want to say what k is? 0 and 1. So what that means is we'll have 2 solutions. We'll start with the w sub 0 and then get to the w sub 1. But I can't work with this guy right away. I need to place it into our good old friend, Mr. Trigonometric form, which we did for de Moivre's theorem in our checkpoint. So if I have 0 minus 81i, how do I compute the r value? Square root of 0 plus negative 81 squared. Close? 81? Because this will just, what? So stare at it for a while. Do you see it now? Okay. So we're gonna end up with the 0 goes away, and when you square something, it becomes positive, right? So you're going to get 81 squared. When you square root it, you're just going to get the 81. Now, I get that, folks, but let's think of an easier way about it. We all like easier, right? So instead of thinking of this arithmetic and formulaic approach, let's think about the actual graph. You did learn how to graph 0 minus 81i, did you not? So where is it? Really down far on the y-axis there. Good, negative 81. Everybody agree that that's where I'm sitting? So how far is that from the origin? 81. See how I can do without actually... Yep, feel free to make the picture whenever you want. Everybody see we're 81 units away? Okay, then let's determine theta. So I got to determine theta. Instead of setting up tangent of theta is equal to b minus, or b over a, which is fine if you want to do. Can somebody else tell me where's my location? 270 converted to degrees. Three pi over 2. All right, great. Okay, good. Nice job. So, so if you wanted to set it up, you could figure out that same way. But does everybody agree that looking at the graphical location is a good argument? In fact, the earliest mathematicians that worked with the complex analysis numbers that we're doing, they would make more graphical arguments for their work than they would actual algebraic arguments because it works out so cool. So here we go. Z is equal to my R value, 81, times the cosine of, what's my angle? 3 pi over 2 plus I sine 3 pi over 2. Awesome. So we're beginning, and you guys are going to take over the next one a little bit. I have to start with W sub K. Anybody know I got W sub what? 0. I start with the 0, and then I'll move to the 1. This will allow us to find one of the roots of the square root of negative 81i. Look at your formula. What do I start with? Even before the cosine. R, what's R? 2 the what? 1 over, and what's n? 2. Good. Times the cosine of 3 pi over 2 plus, oh boy, 2 pi k, it just throws you for a loop, doesn't it? Well, what's k? 0. Over why 2? Because it's divided by n, and that's what n is. N is 2. Plus I sine of, okay, let's try to save some space here then. So 3 pi over 2 plus 0 is 3 pi over 2 divided by 2. Three pi over 2 divided by 2. So we multiply by reciprocal. You get 3 pi over 4. Everybody see that? So we had to write that out in all the other classes as well. And, you know, I know the fractions get us. We're predisposed to ultimately hate fractions, and that's just the way it goes. So, yeah, it's going to, yeah, we just did that so we could save some space here. So I've got 81 to the 1/2. Does that work out? What is it? 9. Cosine of plus I sine of 3 pi over 4. Wasn't that awesome? That's what we call trigonometric form of your result. Now, we're not sitting just in trigonometric form. What else do you want? Complex form. Well, you tell me, is this 3 pi over 4, is that an angle that we like? Yeah, how many degrees is that? 45. How many of the 45s? It's 135. It's 3 of them. Good. We're sitting over here. So I've got my 45-degree angle. Great. So somebody give me the terminal point that arises there. Somebody had it earlier today. Good job. So now all of a sudden, when I want to be able to write this in complex form, I just have 9 times negative root of 2 over 2, because cosine is the x value, plus I times the root of 2 over 2, because sine's the y value, and I distribute. Now, we still got to do W sub 1, right? But let's pause and smell the roses for a second. Because, okay, thank you. It's not that bad, okay? It's like getting a root canal, all right? So, all right, so this is Gigi Otten's question. She says, so what does it even mean, Mr. Gens? That is a good question, yeah. So you tell me, what does that mean? Okay. What was our original question we asked at the very beginning? Square root. So that means if I take this and multiply it by itself, I should get negative A1I. I remember the first time I did this, I was sitting in pre-calculus class just like you guys. And I was like, I was like, really? Like if I were to take that guy and just multiply right by itself, like FOIL it out? Yeah, I did. Yeah, I did. Yeah, well, I wanted to see, was it going to work out to negative 81I? Just like, is it really going to work? And it did, and I was fortunate. I was like, yes, it actually works. So if you guys get some time later, it actually wouldn't take that much time. You could do it during the halftime of one of the games that you're going to watch tonight, okay? But like FOIL it out, and it works. But I'm not done because the theorem says that we don't just have one solution. We have a second solution, and it exists for W sub 1. It's like just gift that keeps on giving. So we've got But let's see if it gets easier here. So what do we start off with when we do W sub 1? 81 to the, which is just 9. I mean, we've already done that. 9. Cosine of what's our angle? Not your new angle. 3 pi over 2 plus. Oh boy. K isn't 0 anymore, is it? K is 1. 2 pi. All over 2. Oh man. Yeah, it was a good run, wasn't it? It was a good run. Well, I think we could maybe do that. 3 pi over 2 plus 2 pi. That'll be 3 pi over 2 plus 4 pi over 2. 7 pi over 2 divided by 2. 7 pi over 4. Hey, that wasn't that bad. We're pretty good at fractions, aren't we? Yeah. Yeah. So I got 9 times the cosine of 7 pi over 4 plus I signed of 7 pi over 4. What do we call that guy? Yep, trigonometric form. And what do we want to do with that? Turn it into complex form. Oh boy. I wish I knew what 7 pi over 4 was. Oh, it's 315 over here in the fourth quadrant. 45 degrees. What's my terminal point? Root of 2 over 2, negative root of 2 over 2? Okay. And as I multiply that through, I guess I probably get 9 roots of 2 over 2 minus 9I roots of 2 over 2. And so that's my second result. Definitely similar to the first, not the same. You be careful to make too many inferences about predicting what kind of solution is going to come next. The negatives and the i's can play tricks on you. Isn't it incredible how much trigonometry we had to do to get from beginning to end? It's kind of a good summary of everything we've done this quarter, isn't it? Hopefully you... Oh, this semester, I guess, from the beginning. Okay. All right. Good. Okay, I get it. I get it. It's easier when Mr. Gens is up there, right? Okay, it's easier when Mr. Gens is up there. So let's try to start to remove me a little bit. So, yep. So where do I start? Okay. Okay. Radius. 27. Okay, we got a couple questions going here. First of all, Parr says that the radius is 27. He's already at that spot. Is everybody convinced that the radius is 27? Parth, how'd you get there? You just pictured it? You pictured plotting the point. It was just like the last one, right? It's down on the y-axis, and it's 27 units from the original location. Okay? Rach, you had a question pop up. You're okay? Okay, so you saw the 3 within the third roots. That was where we were? Got it. Read the word. All right. So theta. Y 3 pi over 2. 270 degrees, which is 3 pi over 2. Okay, so we've got the location. So you were actually able to think about the location, be able to determine those. It was similar to the last one, so good for you. So what's the trigonometric form? Z is what? 27? Good. Okay, good. You guys carried me there. Am I done? No, and we're just beginning. So the goal is to find the cubed roots, the third root. So what? W sub 0. Good. Cosine of 2 pi over 2 plus y. Okay, because k is 0. Is it over 2 or over 3? Because n is 3. Plus I sine of, let's save some space here. 3 pi over 6, which is pi over 2. Good. Okay, sweet. (27 to 1/3). What's 27 to 1/3? 3 times the cosine of what? Pi over 2 plus I sine of pi over 2. I'm sorry, you caught it. So yep. So when you see that pi over 2, sometimes we think it's 180. Actually 90, not much different, just a flip of the zeros and the ones. So all right, what do we call that? Trigonometric form. And what do I want to do? Get it in complex form. So Sam, you were already doing this earlier, so you found this location. Pi over 2 is the same as. And what's our location? 0, 1. Which value is cosine? Which value is y? So 3 times 0 plus I. 3i. Hey, that's kind of nice. Well, yes, we have to do it 2 more times. We're going to, and we're pretty good at it. We're going to pick up on the work we've done, but let's look at that guy right here, because I came up with something that looked a little bit prettier than the previous 2, right? I want you to look at the original problem. Do you think you maybe could have guessed that the cubed root of negative 27i might have been about 3i? Yeah, that one's easy to multiply out, and you can get that. But think about it. There's 2 more solutions. And do you have any reference for what those 2 would be? And I'm right there with you. I've got nothing. So let's lay out the work. So you lead me. What now? Three. Okay, I get to keep that. Cosine of 2 pi. Why 2 pi? Okay. Because our k value is 1. 2 pi k is 2 pi. Somebody, 3 pi over 2 plus 2 pi. 7 pi over 2 divided by 2, 3. 7 pi over 6. That wasn't too bad, was it? That's our trigonometric form. So, okay, good. Everybody understands we got 210 degrees, which makes my 30-degree triangle sitting over here. So my terminal point is negative root of 3 over 2, negative 1/2. So 3 times negative root of 3 over 2 minus I over 2. I have negative 3 roots of 3 over 2 minus 3I over 2. Yeah? That's complex form. You try W sub 2 on your own. Go. People are rolling. Let's see where we're at. I'll try to catch up with you. You should have W sub 2 is equal to, I keep the 3, right? And I got cosine of, and what was the angle turned out to be? 11 pi over 6 plus I sine of 11 pi over 6. Yep, exactly. Then you locate that terminal point. Now we're in the 4th quadrant down there, and you've got positive root of 3 over 2 and negative 1/2. So I've got trigonometric form, and then I finally have here complex form. And you guys see that if I insert those points in here, and you might even want to save yourself a step here. Okay, you might even want to save yourself a step. You might just want to say, okay, that's my x value. Okay, that's my y value. And so I've got 3 roots of 3 over 2 minus 3I over 2. Okay. Hey, that's just... All right. Thumbs up, thumbs down, thumbs side. Okay. You know, hey, guys, I'll be honest. I mean, if you feel like you could carry that out right there, you're on a really good path. I mean, we have time to work on this tomorrow because you're going to need it. I'm not trying to be, not trying to just get you guys to like me. You guys are going to need the time tomorrow. Otherwise, we're going to be in trouble. Okay. Now, last one. We're not going to carry it all the way out. We don't need to. We just want to set it up. Okay. Because this one's 4 solutions, right? But there's a slight change. So let's see how we respond when things get mixed up a little bit more challenging. Okay. We're not going to carry it all the way. Let's just see the setup. What makes this one different from the others? Okay, the negative 1 in front. This isn't simply just located on the y-axis, is it? Okay, so where do I start? N 4. Okay. All right. R theta. Square root of, this looks like it could be challenging. 1. Say like you own it. There you go. Yep. So 309 1/3. What's 1 plus a third? 4/3. So we got the square root of 4/3. So a lot of people are immediately simplifying this. I can hear you talking about you're simplifying to 2 roots of 3 over 3. That's fine. Neither one is really going to help us a whole lot as we move forward. It's just going to end up computing to a decimal, and I'll show you why. But either one of these would be fine right now. So let's just leave that. Let's get to kind of the more challenging piece right now. Let's consider theta here. So how do I determine theta? Because I can't just look at that and determine theta. Tangent theta, b over a. So what is that? Okay, negative root of 3 over 3. So if I've got negative root of 3 over 3, that means tangent is negative. Which quadrants? 2 and 4. Does this one sit in the second quadrant or the fourth quadrant? How do you know? If you were to plot it, go back and then up, I could tell I'm in the second quadrant. We should inverse the root of 3 over 3 on our calculator. What do you get? 30 degrees. So that means that this angle right here is 30 degrees. If that angle is 30, what's my overall angle? 150. Convert it to radians. 5 pi over 6. Ooh, all of a sudden, a little bit more challenging, huh? So I've got 2 roots of 3 over 3 times the cosine of 5 pi over 6 plus I sine of 5 pi over 6. That's trigonometric form. What do I do with it? Fourth root. So we're only going to set up W sub 0 here. That's all we're going to do. We're going to show you what occurs in a lot of these situations because it's different than the others. So what do we start with? 2 roots of 3 over 3 to the... Can everybody understand that that's going to be a ridiculous looking number? We're not going to attempt to place this in the simplest radical form. We're going to convert it to a decimal eventually. You're going to see why with this. Now you get cosine of what? 5 pi over 6 plus 0 divided by 4. Oh my gosh. 5 pi over 6 plus 0 divided by 4. 5 pi over 24. You guys think you're so funny. 5 pi over 24. Is 5 pi over 24 an angle that we know on the unit circle? Not at all. Okay, we can't find that exact value. Okay, so therefore, what we're going to do is we will write this as 2 roots of 3 over 3 to the 1/4 power times the cosine of 5 pi over 24 plus I sine of that 5 pi over 24. And we're going to call that our trigonometric form. And we knew we would be able to do that. But regarding the complex form, we've got no way of finding that terminal point. So take out your calculators. Everybody make sure you got your calculators so we can do this together. Let's make sure we can get this operation correctly. First, we're just going to calculate 2 roots of 3 over 3 to the 1/4 power. I like to actually do the fraction, press enter, and then carry out the exponent. 2 roots of 3, close that parenthesis, divided by 3, enter. Then I'm going to raise that, and you can either raise it to the 1/4 power, or you can compute 1/4 as a decimal, which would just be our 0.25. Did everybody come up with 1.04? If you did not come up with 1.04, check your parentheses or your order of operation. Yeah? Okay. So we got 1.04 times, and now I want to check, I'm sitting in radians, take the cosine of 5 pi divided by 24, and what do you get? 0.79. And then the sine of 5 pi divided by 24. And I get 0.61. If you're not getting those values, what might be wrong with your calculator? You forgot to switch from degrees into radians. make sure you're sitting in your radian measurement, which, by the way, folks, all of your MCA tests that you have, the calculators that pop up, they are all defaulted into radians. So in order to actually make good use of it, you would have to convert it to degrees. How many kids do you think actually know that? Well, yeah, I think that they should put a calculator there that's actually in the correct format. So now I'm going to distribute this 1.04 times a 0.79, and I get 0.82. And then the 1.04 times the 0.61, and we get that 0.63i. And that then is complex form as a decimal. What does it even mean? Close. If I multiply by itself 4 times, I will come up with that thing right there. Guys, here's the good news. You make it through today's lesson, everything after this, I think, gets easier. If you could do this, you could do anything in calculus next year. But this is a lot of work. And without a doubt, I think everybody recognizes you had to use a lot of trigonometry in order to get this piece, right? I'm going to hand out your assignment. It is only 4 problems, but you guys, tomorrow, we need to be super dedicated making sure that those 4 problems, that we are making great progress on them and figuring it out. Ashley, Ishka, can't wait to see you.